Hi, this is Matthew, and this is my submission for the EM3 math assignment using Euler's method.
Okay, so now this was my EM3 explanations for the Euler's method. So now, what is the Euler's method? Well, it is a numerical technique for estimating the solution of initial value problems of first-order differential equations. The method uses known points to predict new ones by estimating y values at points near x. So here is a graph and how the Euler's method is derived. Firstly, Euler's method or his formula states that yn plus 1 equals to yn plus h times f bracket xn comma yn, where yn is the current y value, xn is the current x value, and h is the step size. The graph here shows that Euler's method is an estimation and it will not be 100% accurate to what the exact graph would look like. To derive the formula, we allow dy dx to be roughly equal to yn plus 1 minus yn over xn plus 1 minus xn. Then we let xn plus 1 minus xn be h and rearrange the formula to yn plus 1 equals yn plus h bracket dy dx. Since the differential equation tells us dy dx equals f bracket xn comma yn, we can then sub this into the equation and get yn plus 1 equals yn plus h times f bracket xn comma yn, thus getting Euler's formula. Okay, now I will explain to you how Euler's formula is used in Excel. Firstly, we set the step size h to 0.1, and in the first column A, which is the xn values, the values start from 0 and has an increment of 0.1 due to the step size being 0.1. For column B, the yn values, the initial value would be 1, as the question has stated y bracket 0 equals to 1. And in order to solve for column B, we will use Euler's formula, as these are Euler's estimates for y. And by using the formula yn plus 1 equals yn plus h times f bracket xn comma yn, we can then get the value 1.1 here as shown in the equation above. For the last column C, it is the differential equations, and in order to solve this, we will use the question provided where it says that x squared plus 1 over y, and that equals to dy dx. However, using Euler's formula, it states that f bracket xn comma yn equals to dy dx. Hence, it can also equal to x squared plus 1 over y in this situation, and allowing us to solve the differential equation here. Now, by repeating this all the way until the x values reaches 1, we can then get the Euler's estimate for y, which is 1.911. Hence, this helps us to solve the question using Euler's formula. Okay, so now I'll be solving the equation using the regular method and finding out the approximation error. So to solve this equation regularly, we will just separate all the y's and x's to one side each and solve them accordingly as shown in the workings here. And eventually you would get a value that's about 1.915 rounded up to 3SF. And to find the approximation error is simply the regular method minus Euler's method, which is 1.915 minus 1.911 as calculated from the Excel before, and this to give a value of 0.004.
Okay, that's all for my presentation. Thank you.